Hello, today we are going to be talking about some transformations. Okay, so in front of you, you should see right here this f of x equals a times x minus h, quantity squared plus k. That's a vertex form of a quadratic function. We're going to use this to kind of model and understand our transformations. The first thing that you see here that is a variable is a. A is usually going to appear in the form of a positive or negative number or fraction. Well, let's see what effect it has on the graph. The effect that A has on the graph is reflecting it over the x-axis if it's a negative number, or, right? Could be both, could be one or the other. It's a vertical stretch that happens only if A is greater than 1, or a vertical compression that happens when A is less than 1. Next I see an x, but x is x, just like f of x is y. It's just our graph. So let's take a look at h. All right, so what effect does h have? Good question. The effect that h has on our graph is moving it horizontally. Now this one's funky. When we move to the left, you should see a plus sign. And when we move to the right, it's a minus. And that has everything to do with the original one being x minus h. Lastly, we have k. What effect does k have on the graph? Well, k moves it vertically, up and down. Oh, I didn't color the h in the question. Shame on me. Okay, so luckily for us, k is pretty straightforward. Down is minus, up is plus. It's only the left and right that are kind of backwards. Right. Next, let's name the parent function and describe the transformations. All right. First, the name. The name of this parent function is a quadratic. And I'll type that in. Quadratic. Now let's see what transformations it has. First things first, I see an a. I see a minus sign. There's no number. It's just a negative. So what we have here is actually just a reflection over the x-axis. That's what that minus sign is telling us. There's no stretching or compressing because it's not like -3 or something like that. Let's take a look at h. We have a +3, which actually means left 3 units. Boom. Next, we have a -11. This -11 is down 11. Let's do some more. Once again, we have a quadratic. In front of, so our a, in front of the parentheses, we have a 1/3. So really what that means is vertical compression by 1/3. Next we have a -4 in here. For us, that means right 4 units. I don't know why I typed a 2. My fingers just decided to do their own thing. And lastly, I see a +1, which is up 1. Boom, boom. Alrighty. Oh, this is a different one. This one has these 2 vertical lines. You know what that means? That means this is, boom, boom, an absolute value function. All right, let's check this out. In front of our absolute value, I see a 2/3. So this is a vertical compression by 2/3. If it was a number greater than 1, it would be a vertical stretch. All right, let's color code. Boom, boom, boom. Color, color, color. Color. And lastly, we have a -9. This is inside of the absolute values, which is the same as thinking about inside parentheses. They're grouping symbols. We're going right 9. Okay, one more. We have this cube in the root, which makes this a cube root function. Next, we have something underneath the root, similar to something being inside parentheses or inside the absolute values. -5 means right type to 4. Let's go, man. Right 5. And we have a -7 outside, which means down 7. Okie-dokie. All right. If you have any questions, don't hesitate to ask me or whoever your teacher is. Oh no! Oh no! Okay, there. Much better. Okay, so now we're going to name a parent function, list the transformations, and graph them. Okay. Well, first things first, this is a quadratic. I see that it's going right 1 and up 2. Okay. Right 1. Excuse me, up 2. Okay. So we are going to take our original parabola. Let me graph some points. Let's do 2, 4, -2, 4. So luckily about this guy, you can do, since we're just going right and left, right and up, I'm going to take quite literally, whoops, my bad, every single point, and I'm going to move it to the right 1, up 2. Right 1, up 2. Right 1, up 2. And there it is. Wow, that's ugly. That's okay. Let's continue. Ooh. Now this one, we're going to have to write down some original points. This is not just moving right and up. This one has a stretch. First things first, this is an absolute value function. We have a vertical stretch. I forget the T all the time. By 2. Right 1. Down 3. Now, vertical stretch by 2, you're going to multiply the y's. I'm going to use some original points of our function to do all of this stuff because it's just going to make life a little easier. My original points, I'm just going to use 3, -2, 2, 0, 0, and 2, 2. The first thing I'm going to do is a vertical stretch. I'm multiplying every single y coordinate by 2. Wow, those 2's and 0's looked ugly. For just a little warning, the bell might ring as I'm recording this. I just checked the time. Don't freak out if you hear a loud bell noise. Color coding. vertical stretch, a vertical stretch, and I just did my y's. Then, of course, right 1, down 3. I'm going to do that at the same time. Right 1. I'm going to zoom in a little better to make my handwriting. Right 1, down 3. I'm going to do them at the same time because why not? They're just adding and subtracting. I'm going to add 1 to every single x value because I'm moving to the right. When you move to the right, numbers become larger. Then down 3 means I'm subtracting 3 from all of my y's, moving everything down. Okay. Oh, see, there's the bell. There's that bell. All right, so let's graph the original. Let's graph the transformation. All right, so those dots I picked last time are huge. That's okay. -2, 2, 0, 0, 2, 2. 2, 2. All right, let's graph this beautifully. Since these are straight lines, I could actually use this. Okay, so that's our original one. And let's do our transformed one in purple, because that's what I guess I feel like right now. All right, -1, 1. 1, -3. And 3, +1. Okay. So, since we had a vertical stretch, you should see this become narrower. And because we have a movement right and down, you should also see that not only did it become narrow, it moved right and then down. Okay, so much better than this one, right? I wish I could get a U-shaped drawing utensil on here, but alas, alas. Okay, let's do our last one here. In this case, we have a square root. We have right 5. I wrote a 3. Of course. Good job, Miss Woman. Up 1. All right, let's color code. Let's color code. Right 5. Up 1. Okay. I'm going to draw the original. What did I do it in blue for that one? Let's do it in blue for this one too. If I could just, oh no, you're okay, computer. Chill, chill, chill. Okay, it chilled. No, it didn't. Ah, okay, now it's chilled. Okay, let's graph the original. The original, we have 0, 0, 1, 1, and 2, 3, 4, 2. So this would be our original point, original graph. And let's do some transforming to it. I'm going to move every single point, right 5, up 1. 1, 2, 3, 4, 5, up 1. 1, 2, 3, 4, 5, up 1. 1, 2, 3, 4, 5, up 1. So our